In exercise 14G, we're going to start the calculus of trig functions. So you might remember back to our little golden book of differentiation, and we know that differentiation gets the rate of change, or the gradient. We've looked at differentiating polynomials, bring the power to the front, subtract 1 from the power. Exponentials, d to the x of e to the x is e to the x, of logs, d to the x of log x is 1 on x. Now we're finally getting on to differentiating of trig functions. So a couple of things. Be aware that although I've got this in extension 1, this concept, these differentiating trig functions, is not exclusively extension 1, that this will appear in the advanced maths course. And it really is just a matter of learning these. Now, while they appear on the reference sheet, for example, if y is the sine of a function of x, then dy dx is basically cos of x, and if this is some little function in x, then we must differentiate that function. We've seen that concept before. But basically knowing that the derivative of sine is cos. Derivative of sine is cos. Derivative of cos is minus sine and multiply by any appropriate derivative of the x function. And the derivative of tan is sec squared multiplying by the derivative of the x function if it's appropriate or needed. All those other rules, the chain rule, the product and the quotient rules, must also be followed. Just also be aware that when we write sine squared x, we write it like this, but we actually mean sine of x all squared. So you can probably see from there that you would be using the chain rule or function of a function rule, bringing the 2 to the front, subtract 1 to the index, and then differentiating by the function inside the bracket. So d dx of sine squared is d dx of sine of x all squared. Now we're ready to differentiate, so you don't see the d dx on this line. Bring the 2 to the front of sine of x. I've left out the bracket because it's not needed. I've subtracted 1 from the power because its power would then be 1. And then I have multiplied by the derivative of sine x, which is cos x. Okay, let's have a look at these couple of examples. d dx of cos squared is bring the 2 to the front, leave the cos and subtract 1 from the power, which makes it just 1. Then multiply by the derivative of cos, and the derivative of cos is minus sine. Tidying that up, we've got a minus out the front of the 2, and sin x cos x, or cos x sin x, it really doesn't matter. In example 2, we're finding the derivative of tan cubed. I'm ready to bring the 3 to the front. I'm ready to actually do the derivative, so we don't write d dx on this line here. Bring the 3 to the front, subtract 1 from the power, so tan cubed goes down to tan squared, and now we're going to multiply by the derivative of tan, and the derivative of tan is sec squared. I've actually gone on, and I'm not so convinced that I've simplified it, and we would only continue on in order to simplify it. But you can see what I've done there. Tan squared is sine squared on cos squared, and sec squared is 1 over cos squared. I was hoping that it might be the other way around, because then that would have cancelled and actually simplified. But in this case, all I've done is created a denominator of cos to the 4th. And I'm not so convinced that's simplified, but if because I've presented all these answers, then I'm sure I'll get the marks at whatever stage they're expecting me to go to. And like it says here, these need to be either memorised or you're able to derive them because they're not on the reference sheet. And I would say memorise them because there might be a case where you are expected to see that and know it is the derivative of cosec. Now remember, I've been saying that for many questions, it's all about what's presented to you and what you can connect that to. So if this was presented, minus cosec x cot, and you recognised that as the derivative of cosec, you could integrate that and know it went back to cosec. So yes, I would say learn these. The derivative of sec is sec times tan. The derivative of cot is minus cosec. It should not be that difficult to derive them, and being able to derive them is as different to knowing to recognise this or this or this as the actual derivative of a trig function. That's very different. If I was straight out asked to derive cosec x, then I would have d dx of sine x to the minus 1, because that's what cosec is, 1 on sine, or sine to the minus 1. Because I'm differentiating, I'm not going to write it as 1 on sine. I'm going to give it its power. So then I can actually differentiate it. Bring the power to the front, subtract 1 from the power. That's how you differentiate. Then you go inside and you differentiate sine x to get cos x. So what you can see I've done there is minus 1 over. And I've split, that would be 1 over sine squared x. I've broken that up into sine x and sine x, so that I could put cos on sine, because that creates a cot, and 1 on sine x is cosec x, which is what we've got there. So d dx of sec x is d dx of cos to the minus 1. Bring your minus 1 to the front, subtract 1 from that index, and then multiply by the derivative of cos, which is minus sine. The negative and the negative make a positive. Now I've written cosec x to the minus 2 as 1 over cos x times cos x in the denominator, and I've just combined the sign. So the negative and the negative disappear to be a positive. What do we call 1 on cosec? We call that sec, and sine on cos is tan, which is what we have there. d dx of cot, which is tan to the minus 1, minus tan to the minus 2, times derivative of tan is sec squared. That should be x. And minus tan to the minus 2 is 1 over tan squared. And sec squared is 1 over cos squared. So this is minus 1 over sine squared on cos squared times 1 on cos squared. Minus 1 divided by that is minus 1 times this turned upside down, so it's cos squared on sine squared, times 1 on cos squared. The cos squareds cancel out. We've still got the minus and 1 over sine squared, which will be cosec squared. Well, that's about it in terms of explanation. Hopefully you'll be right to do 14G.